Hello, everybody. So in this video, I'm going to be discussing two-mean hypothesis testing for independent samples when our population standard deviations are unknown. So let me go ahead and share my screen and we'll get started here. So here's our first example. So a customer claims that the planks produced by company A have a different mean length than the planks produced by company B. Assume a sample of 60 planks from company A is taken. The mean is 2.5 with a sample standard deviation of 0.1. And a sample of 65 planks from company B is taken, and the sample mean of those is 2.4 feet. Sample standard deviation 0.05. Our population variances are equal, and our significance level is 0.05. Company A is sample 1, company B is sample 2. So for these types of tests, our null is always mu1 equals mu2. So the mean of population 1 equals the mean of population 2. So in this case, company A equals company B, basically. But that's always your null for these tests. And then I said different than here. So my alternative is going to have a not equal to sign. So the mean of company A is different than the mean of company B. All right, so let's go to Rguroo and enter everything in here. So I'm going to go under Analytics, Analysis, Mean Inference, 1 and 2 population. I'm going to select my data set here. There's no data set, sorry. I'm going to go down here and I'm going to enter my labels for my two variables here. So my first sample is the company A plank length, and my second sample is the company B plank length. So company A plank length in feet, and then my second one is company B plank length in feet. Let me just double check real quick on the notes. So those are the same titles that I used in the one I did in the notes. Yep. Okay. Just want to double check my titles, make sure I'm using the same titles I had in the notes. Okay, so those are my two variable names for my two samples here. And then my first sample, my mean 2.5, sample 60, sample standard deviation 0.1. So 2.5, 0.1, and 60. And then for my company B, it's going to be 65, 2.4, and 0.05. And then we're going to go to population 1 minus 2, test the hypothesis. My significance level was 0.05. And then, so I'm going to enter my alternative in here. So you're going to enter the sign here. So it was not equal to, which is the exclamation point thing. And then you always put 0 in this box. Basically, the way it's writing it. So just to show you how it's writing it here. So we had mu1 not equal to mu2. Basically, what they're doing is they're subtracting mu2 on both sides. And then that gets you mu1 minus mu2 not equal to 0. So that's where they're getting that from, just so you guys know. But basically, you're going to put the alternative sign in the box, and then you're always going to put 0 in the numerical box. Okay, so now, since I don't know the population standard deviations, I'm going to check t-statistic. If I knew them, I would have checked z. And then when you don't know the population standard deviations, you also need to pay attention to whether there's equal or unequal variances. This problem did say equal variances. So you're going to make sure you select equal there, and then you're going to hit the eyeball. So I got a p-value of 6.66 e negative 11. So remember that means times 10 to the negative 11, which is moving the decimal point 11 places to the left. And then our test statistic is right here if you ever ask for that. So once I move the decimal point 11 places to the left, I get this long number here, which is basically 0. So that p-value is less than my significance level of 0.05, which means I'm going to be rejecting the null. And when we reject, that means we have sufficient evidence that the HA is true. So we have sufficient evidence to conclude that the mean company A plank length is different than the mean company B plank length. So my HA in sentence form is basically the mean of company A, which is sample 1, is different than the mean of company B, which is sample 2. So we have sufficient evidence that HA is true, written in sentence form in the context of the question. All right, let's do another one here. An MLB analyst claims that pitcher A pitches faster on average than pitcher B. Took a sample of 100 pitches from pitcher A. The mean is 92 with a sample standard deviation of 5.2. And then the analyst also took a sample of 100 pitches from pitcher B. Sample mean was 91.5. Sample standard deviation 4.5. Population variances are not equal. Significance level 0.01. Pitcher A is sample 1. Pitcher B is sample 2. So as always with these, the null is always mu1 equals mu2. My alternative here, so I'm saying pitcher A pitches faster than pitcher B. So that means so pitcher A sample 1, so mu1 greater than mu2. So let's go to our Rguroo and enter everything in. I'm going to go ahead and close this out here. Analysis, mean inference, 1 and 2 population. So my variable names and the labels here. So my first sample was the pitcher A pitch speed in miles per hour. And my second sample, my second variable is pitcher B pitch speed, miles per hour. Let me just double check that's what I put on here. Yep, okay. And then let's put in all our information for our samples. So my first sample was 100 pitches, sample mean of 92, 100 pitches, sample standard deviation of 5.2. My second one, pitcher B, 100 pitches, 91.5 and 4.5. Okay. And then we're going to go to population 1 minus 2, test the hypothesis. My significance level was 0.01. And then, so I have greater than for my alternative here. So I'm going to put greater than 0. Remember, you always put 0 in the box. Then I'm going to check T statistic because I don't know the population standard deviation. If I did, I would have checked Z. And then it told me unequal variances here, so I can keep that as is. Yep. And then I'm going to hit the eyeball. I get a p-value 0.234, and then this is the test statistic if you ever ask for that. And if you ever want to save it, you can put a title here and hit Save As. So that p-value is higher than my significance level of 0.01, so that means I'm going to be failing to reject. If we fail to reject, that means we don't have sufficient evidence that my HA is true. So I don't have sufficient evidence to conclude that the mean pitch speed of pitcher A is greater than the mean pitch speed of pitcher B. So once again, that second part is basically writing my alternative here in sentence form in the context of the question. So the mean of sample of population 1, which is pitcher A, is greater than the mean of population 2, which is pitcher B. All right, let's do one more like this, and then we'll do some with data sets. Park ranger believes the trees in Park B are taller than the trees in Park A on average, and the distributions are normally distributed. So we have 25 trees from Park A, sample mean 100, sample standard deviation 6.25. We have 22 trees from Park B, sample mean 103, sample standard deviation of 5, significance level 0.1. Park A is sample 1, Park B sample 2. So our null is always mu1 equals mu2. So my alternative here, so I'm saying Park B is taller than Park A. So Park A sample 1, so that means mu1, which is Park A, is less than mu2, which is Park B, since Park B's trees are taller. Once again, or on these types, just be careful with when you're reading the wording that you have your direction correct. And then I'm going to go to our Rguroo here. Let me close this out here. Analysis, mean inference, 1 and 2 population. So I'm going to go ahead and put in my variable names here. So I think it's Park A, tree height in feet. That's my first variable. And then Park B, tree height in feet. That's my second variable. Just double check my titles here. Yep, okay. Just want to double check that I match the notes here. You could put anything in these boxes in theory, but you will need something there to make it run. So Park A, 25 trees, sample mean 100, sample standard deviation 6.25. 100, 6.25, 25 trees. And then 22 trees, sample mean 103, sample standard deviation 5. All right, population 1 minus 2, test the hypothesis. My significance level, I believe, was 0.1. And then, so my alternative had a less than sign. This is going to be less than, and then 0 is always what goes in the box here. Then I'm going to check t-statistic because I don't know the population standard deviation. If I did, I would check z. And then if you're not told if the variances are equal or not equal, which we weren't told here, yeah, we were not told, then you always assume they're unequal. Hit the eyeball. I get a p-value 0.037, and then this is a test statistic if you're asked for that. So that p-value is less than the significance level of 0.1. So that means that I'm going to be rejecting HO, rejecting the null. And if we reject, that means we have enough evidence that the HA is true. So we have sufficient evidence to conclude that the mean height of the trees in Park A is less than the mean height of the trees in Park B. So we have sufficient evidence that HA is true, writing HA in the context of the question. All right, let's do some with data sets now. So researchers believe college students spend less time on social media on a daily basis on average in comparison to high school students. And then we have our two samples, and then we have the significance levels 0.01, and the population variances are equal. College students is sample 1, high school students is sample 2. So our null for these is always mu1 equals mu2. And then the alternative, so they're saying college students spend less time than high school students. So college students is sample 1, so mu1 less than mu2. So let's go to our Rguroo and enter all this in here. So let me close this out here. So I'm going to go to the 10.2.10 downloadable data sets. I'm going to download the social media hours data set. I'm going to import it. So data import, import data set. Choose the file here from my downloads folder. And then for the header on the first line is if you have a title in the first line, my data sets always do. Double check to make sure the ones on Newton do. If they don't, then you would select no header, but they should. Hit upload. All good. So now we're going to go to analysis, mean inference, 1 and 2 population. I'm going to select the data set and the two variables, which are college and high school. We weren't given population standard deviation, so I'll leave that blank. Population 1 minus 2, test the hypothesis. Significance level is 0.01. And then we had less than here for my sign. And then we always put 0 in the box. And that is t-statistic because we don't know the population standard deviations. And I told you the population variances were equal, so we need to change that setting. Yep. And then I'm going to hit the eyeball. P-value is 0.283, and then this is the test statistic if you're asked for that. So my p-value is higher than my significance level of 0.01, so that means I'm going to be failing to reject the null hypothesis. If we fail to reject, that means we don't have sufficient evidence that our HA is true. So we don't have sufficient evidence to conclude that the mean amount of time spent on social media on a daily basis by college students is less than the mean amount of time spent on social media by high school students. Once again, writing the HA in the problem, in the context of the problem in sentence form. All right, let's do another one here. So an NBA analyst claims that the mean wingspan of Eastern Conference teams is different than Western Conference teams. And we have our two data sets. Our significance level is 0.1, and the population variances are not equal. Eastern Conference is sample 1, Western Conference is sample 2. So our null is always mu1 equals mu2. I told you different than here, so my alternative is going to have a not equal to sign. So let's go to our Rguroo and enter everything in. So I'm going to close this out here. I'm going to go ahead and delete the data set. So right click, delete the data set. And then I'm going to go to Blackboard and download the 10.2.10 wingspan data set. Data import, import data set. Choose the file here from our downloads folder. Remember, you select first line header if you have a title in the first line. If you don't, then you would select no header, but you should double check that on Newton. Mine always have a header. Hit upload. And then we're going to go to analytics, analysis, mean inference, 1 and 2 population, select the data set, select both variables. We weren't given population standard deviation, so we'll leave that blank. Population 1 minus 2, test of hypothesis, significance level is 0.1. And then it's going to be not equal to, because our alternative sign was not equal to, and then always put 0 in this box. I'm going to check T statistic because I don't know the population standard deviations. If I did, I would check Z. And then I believe we were told unequal variances. Yep. So that means we're going to leave that as is. With the eyeball, I get a p-value 0.073. And then this is the test statistic if you're ever asked for that. So that p-value is less than my significance level. Yeah, that's the right p-value. My p-value is less than the significance level of 0.1. So that means I'm going to rejecting the null. And if we reject, that means we have enough evidence to say that the HA is true. So we have sufficient evidence to conclude that the mean wingspan of the Eastern Conference teams is different than the mean wingspan of the Western Conference teams. Once again, writing our alternative there in sentence form. Okay, let's do one last example. Researchers believe that workers at company B work less hours per week on average than workers at company A. And then we have our two data sets. Significance levels 0.05. Company A is sample 1. Company B is sample 2. So our null is always going to be mu1 equals mu2 for these. So I told you company B works less than company A, but company A is sample 1. So that means mu1 is greater than mu2 here because company B works less. And company B is represented by mu2. All right, so let's go to our Rguroo here. Let me close this out here. So I'm going to go here to Blackboard, download the hours work data set. Let me actually go ahead and right click and delete this data set too. So data import data set. Choose the file from your downloads folder. And then remember, if you just double check on Newton, you have a title on the first line. My data sets always do. Hit upload. And then analysis, mean inference, 1 and 2 population. Select the data set. Select the two variables. We don't have population standard deviations, so we'll leave that blank. Go to population 1 minus 2. Test of hypothesis. My significance level is 0.05 here. And then I have greater than for my alternative sign. So I'm going to put greater than. And then 0, because you always put 0 in that box. T statistic, because we don't know the population standard deviations. If we did know them, we check Z. And then unequal variances, because you weren't told either way here whether there was or wasn't equal variances. And then hit the eyeball. I get the p-value of 0.3216, and then this is the test statistic if you were ever asked for that. So that p-value is greater than my significance level of 0.05, so that means I'm going to be failing to reject the null. If we fail to reject, that means we don't have enough evidence that the HA is true. So we don't have sufficient evidence to conclude that the mean number of hours worked in company A is greater than the mean number of hours worked in company B. So we don't have sufficient evidence that HA is true, writing the HA in the context of the question as a sentence. And that is it. So that is two mean hypothesis testing for independent samples when our population standard deviations are unknown. If you have any questions, please feel free to reach out.